Virtual Studio's mock mode is a tool that speeds up iteration time when building an AR experience in Unity. ARDK features like AR, context awareness, and multiplayer are mocked in C# so your app can run completely inside the Unity editor, and you can quickly test changes to game logic without having to spend time building and deploying your app onto a mobile device. This tutorial will cover how to write code that you can utilize Visual Studio's mock features, how to set up a scene with a mock environment, and lastly, how to interact with that mock environment. Step 1. Writing your code. ARDK abstracts away the differences between running your app live on a device and running it in the Unity editor, so your code should look the same regardless of what platform it's being run on. For the example here, I've opened up a completely new scene and I'm going to write a simple mono behavior component to create and run an AR session. And we'll call the component example manager. So inside my example manager class, I'm going to create a class variable, type I AR session. And then in my start method, I'll create the AR session. And then run it, just using the default AR world tracking configuration implementation. So all mocking happens at a level that's abstracted away from the public API. So the AR session factory.create method will return an object of type IAR session, like you can see in line 11 here. And that can be used in the same way regardless of whether you're running the code in editor or on a device. If you look at the classes that implement the IAR session interface, so you'll see an internal native, mock, and remote implementation. Inside those classes, it's a different logic for running a session on the different platforms. And this is the same for the multi-peer networking and the AR networking interfaces. Everything in ARDK is written so that platform differences are abstracted away, and you, the developer, only have to write one single version of the code. Now on to step 2, setting up the scene. To do that, I'm going to add the component I just wrote to a new game object in the scene. And I'm also going to drop in an AR scene camera prefab and delete this default camera that came with the scene. So the AR scene camera prefab has an AR rendering manager to take the image buffers from AR frames and render them to the screen, and also an AR camera position helper to take the AR frames, AR camera's transform value, commonly known as your device pose, and use it to move the Unity camera around in the scene. I could also instead add an AR scene manager prefab, which contains the same AR scene camera and also an AR session manager for creating and running an AR session. But for this example, I wrote my own code to do what the AR session manager does for you, just to show exactly what's happening and how no extra code is needed at all to use mock mode. So far, there's nothing different about how I've set up this scene and how I'd set up a scene to run normally on device. Now for the different part. Create a mock environment to run AR in. Inside ARDK examples, there's a prefab called mockup scene that I am just going to drop in here. You can either copy this prefab into your own project or use it as a base to create your own mock environments. 2 things about this prefab though. First, there's a mock scene configuration component on the root, which will destroy this object in the awake frame if the scene isn't being run in mock mode. So you can deploy this exact same scene to your phone and you won't see these game objects. Second, all these game objects are in the ARDK mock world layer. You can see, the layer is ARDK mock world. And that's so that ARDK knows that these objects are quote-unquote real-world objects compared to virtual objects that, say, you might spawn into your scene. If you don't see ARDK mock world as an option, go to your project settings, tags and layers tab, and you can add ARDK mock world as a user layer. Now let's actually play this scene. To do that, I'm going to open the Virtual Studio Editor window, and that's just in the Unity toolbar and the ARDK tab, open Virtual Studio, and then select the Mock tab, Mock, to let Virtual Studio know that I want to use mock ARDK functionality. and then I just press play. Once the AR session is running, I can use the WASD keys to move laterally and front and back, and the QE keys to move up and down, and the right click on the mouse to rotate. If I go back to the inspector, you can see the AR scene camera's transform value moving in response to the keyboard and mouse inputs. And these inputs aren't actually directly controlling the camera. They control the AR frames, AR camera's transform value, which, like I mentioned before, the AR camera position helper here component is using to move the referenced Unity camera. And that's exactly the same flow of data as would happen on device because, again, all mocking happens at a level that's abstracted away from the public API. So this scene will run exactly the same on a mobile device or through a remote connection to a device, except of course the AR data and camera feed will be supplied by your device instead of by the Unity editor. On to step 3, detecting mock planes and spawning objects on them. The logic here will be super simple. It's basically just to show how to mock touch input in the Unity editor. So back to my IDE and the example manager class. In the update method, first I want to check if there is touch input or not using the platform agnostic input API. That's input.touchCount and check if that's 0, and if it is, there's nothing to do because no touch has been registered. Platform agnostic input is a class that unifies Unity's mouse and touch input APIs. Left mouse clicks in the Unity editor will register the same as touch input on a mobile device. So you can use this class to be able to play through your application in the Unity editor as well as on a mobile device. So after that, I'm going to just get the first touch input that there was and save that in a variable. And then check that the phase is touchPhase.began. And this will only be true when you first tap on the screen or on the mouse down click. If the code reaches this point, I'm going to loop through all the existing plane anchors and spawn my prefab on each one. So then I go for each anchor in the session's current frames anchors collection. If the anchor is a plane anchor, I want to get the transform of that plane anchor, which is a 4x4 matrix. And then I want to instantiate a prefab at that transform. So go back up here, we'll add a variable for the prefab that we want to spawn, and then spawn that down here. One last thing to do. So of course this code is running in the update loop. So I need to check if the AR session is actually not null, because on device, it can take a second for the session to get up and running. First thing to do, in the example manager component, I need to set a value for the prefab that I want to spawn. So I'm just going to use a random Q prefab that's already in the ARDK examples project. Second thing to do, I need to enable plane detection in this scene. To do that, I'm just going to add the AR plane manager component. And this is the exact same one that I would use for a scene running on a mobile device. And set that up as well. This plane prefab is in the ARDK package. And then detected plane types, we'll set it to just horizontal planes. So the only mock mode specific thing that I need to do for this scene is to add a mock plane anchor component to tell ARDK how to find a plane in this mock scene. When you look at this mock-up scene prefab, you can see that some of the objects already have a mock plane anchor component on them. So this cube here, which forms the top of the table, has this mock plane anchor component. This component tells ARDK that there is a plane here, and ARDK will surface a AR anchor for that plane, just as like on a mobile device, it would surface an anchor for a plane it actually detected in the real-world environment. The time it takes for ARDK to discover this mock plane is configurable. So say you want to test how your game reacts when there's no plane discovered for a long time, like 20 seconds, just set this value to 20 seconds. Or if you want to test the other end, how your game reacts when a plane is discovered immediately, set the value to 1 or 0. I'll set to 1 here. Now, when I play the scene, after a second, you will see that the planes are detected. I zoom in here, planes, and then when I click the screen, cubes spawn on each plane.